All right, so we're going to finish up 15.9, dividing complex numbers. And so just like when we had the radicals in our denominator, we had to rationalize those. Now we're going to try and eliminate the I, the imaginary part, out of the denominator. So we're going to remember to use the conjugate of the denominator. So that denominator is going to be the same terms, just a different sign. So we are going to multiply by 9 plus 4i over 9 plus 4i. And we're going to have to FOIL in the top or distribute, depending on what we have in the original fraction. And in the bottom, we are just going to do the first and the last. So in this one, I am going to have to FOIL. So 3 times 9 is 27. The outer gives me 12i. The inner gives me negative 36i. And the last, be very careful because I times I is going to give me that I squared, and negative 4 times positive 4 makes that negative 16i squared. And I recommend that you write everything down before you start to simplify. Then in the bottom, we just have to do the first. 9 times 9 is 81, and the last to get negative 16i squared. Now, everywhere I see an I squared, that is going to change the sign of the coefficient and eliminate the I squared, because remember, I'm replacing I squared with a negative 1. So negative 16i squared becomes positive 16. And now I'm going to collect my like terms on the top. So I get 27 plus 16. And that will be 43. And then I'm going to take 12i minus 36i, and that gives me negative 24i. And that's going to be all over 81 plus 16, which is 97. Now, sometimes they will have you separate those terms so that you can simplify them, but in this case, they don't have to be separated because they can't be simplified. So either one of those answers is correct, okay? All right, in the next example, I am going to multiply by 1 minus 3i over 1 minus 3i. So I'm going to distribute on the top. So that becomes negative 4i, and then that becomes positive 12i squared. And then on the bottom, I'm going to do first, 1 times 1 is 1, and last, negative 3i times positive 3i makes negative 9i squared. Then I am going to replace this with a negative 12, and replace this with a positive 9. Now, I like to write my real number first, so I am going to take negative 12 and then minus 4i all over 10. And this can be simplified, so I do want to take negative 12 and divide it by 10, and negative 4i and divide it by 10, so that you can see that 2 goes into this and leaves negative 6. 2 goes into that and leaves 5. 2 goes into that and leaves 2. 2 goes into that and leaves 5. So negative 6/5 minus 2i over 5. And I could put it all over one denominator of 5, or I could just leave it like that. All right, so continuing, we're going to multiply by 5 plus 2i over 5 plus 2i. So 7 times 5 is 35, and 7 times 2i makes 14i. And then I do first, 5 times 5 is 25, and negative 2i times positive 2i gives me negative 4i squared. And then I will eliminate that by replacing the I squared with a negative 1, so that makes that positive 4. So 35 plus 14i all over 29. All right, we've got four more problems, I believe. 3 on this page and then 1 more on the next page before we start getting into powers of I. And just want to be careful when you have radicals that you remember how to multiply radicals. So in this one, we're going to have to be very cautious, but these next two are just continuations. We're going to multiply by 2 minus 5i over 2 minus 5i. We are going to have to FOIL. So 2 times 2 is 4. The outer gives me negative 10i. The inner gives me negative 2i. And the last gives me positive 5i squared. All over, 2 times 2 is 4. 5i times negative 5i makes negative 25i squared. Look for those I squareds. This is going to be replaced with a negative 5. This is going to be replaced with a positive 25. So now I've got 4 minus 5, which gives me negative 1. And then I've got negative 10i and negative 2i, which makes negative 12i. And that's all over 4 plus 25, which is 29. Okay. All right, so now we're going to do 7 plus 2i. 7 plus 2i. And we're going to FOIL. Negative 3 times 7 is negative 21. Negative 3 times 2i is negative 6i. I times 7, 7i. And I times 2i is positive 2i squared. All over first 49, last negative 4i squared. So replacing this with a negative 2, then I can collect negative 21 and negative 2 makes negative 23. Negative 6i and positive 7i makes positive 1i, and I do not write the 1 in front. That gets replaced with plus 4, and 49 plus 4 is 53. Okay? All right, and this last one and the one following it, we've got some radicals. So you got to remember how do you multiply by radicals. So we're going to multiply by the conjugate, square root of 6. That should be square root of 6 minus 3i over square root of 6 minus 3i. So square root of 6 times square root of 6 gives me square root of 36, which we're going to be replacing. This becomes negative 3i square root of 6. The inner is also negative 3i square root of 6. And the last is positive 9i squared. All over first square root of 36, last negative 9i squared. And then we replace that with a negative 9. We replace that with a 6. So 6 minus 9, I'm going to circle these. 6 minus 9 is negative 3. Negative 3i radical 6 and negative 3i radical 6 makes negative 6i radical 6. And that's all over. This becomes 6, and this becomes positive 9. And 6 plus 9 makes 15. And so now this one I do want to separate because I can reduce this. And so I'm going to write it out, and then I'm going to simplify. 3 goes into that, 3 goes into that. 3 goes into 6, and 3 goes into 15. So my final answer is negative 1/5 minus 2i radical 6 over 5. Now this last one is very different, and I'm going to show you the way that Hawks is going to want it, because they're going to want you to group your real numbers together and group your imaginaries numbers together, even though you can't simplify it any further. So we're going to start by multiplying by the conjugate, 6 plus 5i over 6 plus 5i. We're going to FOIL, so that becomes 6 radical 6. The outer becomes 5i radical 6. The inner becomes 6i radical 7. And the last becomes 5i squared radical 7. And that's all over the first, which is 36, and the last, which is negative 25i squared. So now what you're going to do is you're going to replace this and make that a negative 5 radical 7. That's all you can do on the top. And then you're going to replace this with a plus 25. So I'm going to show you how Hawks is going to want it. They're going to want your real terms, which I'm going to circle. And you're going to put those in parentheses because you're not going to be able to combine those two numbers. Okay, and then you're going to put your imaginary numbers together, and the only thing that you're going to do is you're going to factor out that I and put it out there. And then in the bottom, 36 plus 25 makes 61. Now, I'm perfectly fine with you leaving it like the top numerator as long as you have changed out that I squared. You don't necessarily have to group it like that, but that's going to be what the Hawks is going to want, okay? All right, so the last thing that we're going to do is we're going to look at powers of I. So we've got I, we've got -1, we've got -I, and then we've got +1. And so it repeats itself in this pattern. We're going to go here, and then we're going to go here, and then we're going to go here, and then we're going to go here, okay? So how we're going to do this is how I say that we're going to remember this pattern. Everything repeats in a pattern of 4. So I say I, 1, and I'm going to put negatives in the middle, okay? So anything that is a multiple of 4, okay, which means that it's divisible by 4 and it has a remainder of 0, will end in this last number pattern, okay? So if I, had I to the 4th power, if I had I to the 8th power, if I had I to the 12th power, I to the 16th power, anything that is divisible by 4 is going to finish out that pattern and be a 1. If I have a remainder of 1, I'm going to have the I be my answer. If I have a remainder of 2, I'm going to have -1. And if I have a remainder of 3, I'm going to have -I. So what I'm going to be doing is I'm going to be focusing on the exponent. You're going to take the exponent and divide it by 4 because our pattern is repeated in groups of 4. So when I take 12 and I divide it by 4, I get 3. And I get a remainder of 0. So that tells me that I to the 12th is the number 1, okay? And that means also down here at the bottom, I to the 20th is also going to be 1 because 20 is divisible by 4. Now, the next few that we're going to look like are not divisible by 4. So 37 divided by 4, that goes in 9 times. 9 times 4 is 36. I have a remainder of 1. And so that tells me remainder of 1, I to the 37th is I. There are other ways to do this. You could think of I to the 37th as I squared to the 18th power times I, because I squared to the 18th power, that's 36 I's, and then one more makes 37. Well, I squared I know is -1. And negative 1 to an even power is positive 1. And then I times it by I, and so either way I'm going to get I. I just think using the remainder is a lot easier than having to write it like this, okay? So then I would take 35, and I would divide it by 4, and that goes 8 times, and 32, and then I would have a remainder of 3. So if I look here, remainder of 3, this is going to be negative I, okay? I'm going to skip the negative one first, and then I'm going to come back to it. So let's try this one. 15 divided by 4 is 3. That's 12, remainder of 3. So I1, negatives in the middle. The third number is negative I. Now with a negative exponent, this one's a little bit tricky. We've got to remember our rules of negative exponents. So we have to make it a positive exponent first, okay? And then 5, if I divide that by 4, it goes once, and I have a remainder of 1. So this is going to be 1 over remainder of 1 is I. And so that would be my final answer. So that finishes up 15.9.